Okay, so we're going to go over sine law, and I've drawn or written out two of the formulas. And the formulas, though I've written two of them, they're actually the exact same formula. Okay, if you notice that this one is just the reciprocal of this one. And what I mean by that is the top and the bottom have flipped for all of them. Okay, now you can do this for any formula. So really you only have to memorize one. Okay, so think of it like this. Say we're working with fractions, okay? And you had a fraction 2 over 4 is equal to 1 over 2. Is that true? Do you know those to be equal?
Yeah.
Yeah, they both equal a half. So let's flip that, okay? And let's see if everything still stays equal. So if I go 4 over 2 is equal to 2 over 1, is that still true? Well, what's 4 divided by 2? Do you know?
2.
Yeah, and what's 2 divided by 1?
1.
It's 2, actually.
Oh.
Yeah. So they're the same. Okay? So, which is really good. So in other words, what this is saying is you just have to memorize one of these versions, and then we'll talk about how it can be beneficial to use one or the other. Okay? How it'll be easier to solve for sides. So for instance, anytime you're solving for the side of something, these lower cases stand for the side of a triangle. Okay? These upper cases stand for the angles in a triangle. So I'm going to quickly just kind of draw out a triangle, and I'll show you how you label it. Using sine law, you can rename any triangle essentially anything you want. Okay? So if this is angle A, the only rule is whatever's opposite of it has to be called or labeled that same letter, just we use the lowercase to represent it. So that's side A. Okay? If this is angle B, that means that opposite side is side B. Okay? And if this is angle C, that means that opposite side is side C. Okay, so we have to keep that in mind whenever we're talking about our sine law here. So if they're referring to side C, okay, then angle C would be opposite of it. Okay, really with this formula, what we're doing is we're just plugging information in. Okay, so anytime we're solving for a side, that's the lowercase, it's usually easiest to use this formula here. Okay, anytime we're solving for an angle, it's usually easiest to use this formula because whatever we're solving for is on the top of the fraction. So we just kind of try to keep that in mind. Okay, so all you have to really do is memorize one of these. I usually have this one memorized and then I flip it. But here, more importantly, here's a question. And they have an x, a y, and a z. And according to what we have, this would be angle z, this would be side x, and this would be side y, right? But all of our stuff is a, b, and c. So we're just going to rename the triangle. Okay? They want us to find x, y, and z. Well, I'm just going to rename everything. And we can pretty much call it whatever we want. Now, because this is a right angle triangle, usually they call the longest side the hypotenuse to C. But for our sine law, it doesn't actually matter. We can call it anything we like. Okay. We'll stick to that just because we know it usually helps us. So our x, I'm going to call that angle A now. Okay? Which makes what side side A?
That one.
What number's there?
5. Yeah,
that's right. Okay. Let's call the opposite, that y, we'll call that angle B, which makes which side side B?
10.
10, okay. And if that leaves us with this being side C, okay, what would be angle C?
The right angle.
The right angle, or what does that stand for? How many degrees is that?
90.
Yeah, 90 degrees, okay. So, let's say I want to solve for my angle A first. Well, I'm going to refer to this formula here. It'll just be easiest if we have the angles on top. Okay, so when we do sine law, let's go here. We have sine A, and I guess I'll put it in red so we get used to referencing it. Side A over side A, so that's angle A over side A is equal to, I guess I'll write everything in black in first. Let's get that silly thing out of there. Okay. Is equal to angle B. Oh, I want that to be blue. There we go. Angle B over side B, which is equal to angle C over side C. Okay, I've color coded them to help us out here. So what we're going to do is just plug in whatever information we have here. Okay. Now in this case, well, what actually happens here is our sine law, we can't quite use it yet, and I'll explain why. Let's plug everything in. So what piece of information do we have about A? We have 5. Yeah, we know that we have the 5. So, and that's the side, so I'm going to plug 5 in for that little A there. And I'll do the rest in black just because it takes a while to go back and forth. Do we know what angle A is? Do we know the measurement? No, we don't. Okay, so sine A over 5 is equal to sine B. Do we know angle B, what it's equal to? No. But do we know the side?
Yeah.
Yeah, what is it?
10.
10, that's right. And is equal to sine, do we know the angle of C?
Yeah.
Yeah, it's 90, right?
Yeah.
Do we know the distance of the side C?
No.
No. So, the one rule with sine law is in order to use it, you have to have a complete ratio. In other words, I have to have at least one angle and opposite side. Do I have that in any of these cases?
One angle and one opposite side?
Yeah. So look, we have the side here, but we're missing the angle. We have the side here, missing the angle. We have the angle, but we're missing the side. So as of right now, we can't even use sine law. Okay, but luckily, because there's a right angle triangle, I can solve for C, can't I? Do you know what I can do? What formula we can use to solve for side C?
No.
No? Okay, do you remember Pythagoras Theorem? C squared equals A squared plus B squared?
A little bit.
Yeah, okay, this deals with the hypotenuse, okay? So C is our unknown. And this is our A and this is our B, so let's plug those in. C squared is equal to 5 squared plus 10 squared. So because it's a right angle triangle, we can use this to find the hypotenuse. Okay, and I'll just kind of shove it over to the side here. C squared is equal to 5 squared is 25, and 10 squared is 100. So C squared equals 125. And in order to get C by itself, I have to square root, bring it over the other way. Okay, so C is equal to the square root of 125, which with our calculator we can find out. 125 square rooted. Oh, where's my square root? Here it is. It is 11.18. Okay, so C equals 11.18. So now we have that measurement. So we can now use our sine law. So let's write it out here. Sine 90 over 11.18 is equal to, and okay, so we now have that complete ratio, which is good because sine B over 10 and sine A over 5. Okay, so because we have that complete ratio, we can choose what we want to solve for. So let's say we want to solve for our A first. Okay, well we only need two of them. We need the complete ratio and what we're looking for. This one in the middle, it's not important. So we can really just drop it out. Since these equal signs are saying that everything's equal, we'll get rid of what's there, okay? And we'll just work with the two. So let's work with sine A over 5 equals sine 90 over 11.18. Okay, and the goal will be to isolate A. How can I bring this 5 to the other side if it's divided on the left side here? Because it's divided by 5. How can I bring it to the other side? What opposite operation could I use?
Multiplication.
That's right. So when I bring it to the other side, this 5 has to become multiplied by 5. So then what we'll have is sine A equals sine 90 over 1.18, okay, times 5. That's good. So now we can equate all this. So let's actually go about equating this, okay? So let's do the sine 90 first, okay? So 90 sine is 1 divided by 11.18 and then times 5. 0.44722. Okay. 0.44722 equals sine A. Do you think that's the degrees?
No.
Are we done? Have we isolated just for A? What's still on this side? Sine. So we have to bring sine over. And when we bring sine over, it actually becomes the inverse. Do you recall using that ever last year?
No.
Use sine inverse anytime you're looking for a angle. Okay, so we have to use sine inverse, and you'll find it on your calculator. You have to hit the inverse button. So we find the inverse of that. So we take that, and I have to hit shift. So here's sine, and when I hit shift, it's sine to the power of -1. Okay, so I hit that button, 26.56, and we have a measurement. A equals 26.56 0.56. That's great. So, according to this, angle A is 26.56, so we could say approximately 27 degrees. Okay, so doing what we just did there, I want you to try angle B using sine law. Okay? Okay, so if you use sine law to solve it, you would have got a number. Another way we could have solved it is all the angles in a triangle have to add up to 180 degrees, right?
Yeah.
So since we have two of them, we can subtract those two from 180 and find out what it's equal to, right? So if I take 180, I know I have 90 degrees, I subtract 90, well 180 subtract 90 is going to be 90. And then I take my approximately 27 and I subtract that, that's actually going to give me 63. So angle B would be 63. Okay? So with that being said, we've solved everything. But let's say for some reason they give us these two angles and we want to know how to solve a side, because we haven't done that yet with this. We're going to prove side C is the length that we said it is, okay? I'm going to take one of our other ratios, okay? So I rounded a bit. So I'm going to use this 26.5 because that's the true one, and the 5. And those are both our side A. So I'm going to scroll down and give myself some room. Actually, you know what? I'm going to jump to a new page. So remember with our sine law, we had sine A over A, B over B, and C over C, right? And side A was 5, in case you don't remember, just zoom back there. And the angle was actually 26.5, okay? Sine B, we actually know B was, we approximated it to be 63, and the side was 10. And our angle was 90. Let's say we didn't know what side C was, okay? And we want to use this one just because we didn't do rounding. We did do a little rounding here. So remember I said you only need 2. So I'm going to pair up these two. We're going to drop the middle one. We only need 2 in order to solve this, okay? So let's drop that off. So that now leaves us with sine 26 over 25. Sorry, sine 26.5 over 5 equals sine 90 over C. Now remember I said it's easier if what we're solving for is on top. Well, this is where we're going to flip the equations, right? It's because that'll be a lot easier to solve for us. So let's flip these two equations. Okay? So when I flip them, it's actually going to say 5 over sine 26.5 is equal to C over sine 90. Okay? Now this might be a lot easier if we do this. Let's do each one step at a time. Okay, so we get some decimals and we're a little stronger with our math. Sine 90, it turns out that sine 90 is just the number 1. Okay, and so I'm going to replace that with 1. And 26.5 sine, that's the one we're going to figure out. 26.5 sine 0.4461. Okay, so let's replace these. We know that over here it's 1. And over here, sine 26.5 was 0.4461. So 0.4461. Okay, so I've got rid of those signs and now I'm just working with decimals. Do you know what C divided by 1 would be?
C?
Yeah, that's right. It would just be C. So that makes it easier. C is equal to 5 divided by 0.4461. Had this been another number, like 2, we would have had to bring it over, and when we brought it over, we would have had to multiply by 2. Okay. All we have to do is divide these values, and we're going to get what C is equal to. So 5 divided by 0.4461 is 11.2, and remember we got 11.18, right?
Yeah.
So it's pretty much the same number. We're always going to have a little bit of variation there. We got 11.2, but if you look back before, we originally had gotten 11.18, which is really close. It's 2/100ths of a decimal point off there. Okay, so let's do a page. Okay, so there's everything we did. We solved for the angle, and we figured out how to solve for the side also.